So let's look at the problems for 3-1. I can get that going. And is that big enough? Can you guys see that? Now you can. Okay. Find an equation for the line tangent to y equals 4 minus 3x squared at this point. Okay? So you're going to use that definition that we've been doing, that f, and I'm going to write it here. M equals the limit as h approaches 0. Okay? So, how would we start that? If we're going to write the equation of a line, we've got to find the slope first. So that's what you're going to do first. And if we're going to find this, we got to plug in. So we've got limit as h approaches 0 of, what is f of x plus h? What is that telling us to do? We're using this equation right here. So wouldn't we have 4 minus 3, and instead of x squared, what do we have? 4 plus h. Okay, and then we subtract f of x. Well, what's f of x? F of 4 is negative 44 over h. Okay, one of the things that I watched as I was grading, sometimes we had trouble with squaring those things or cubing those things. By the time you finish these couple of sections, you should be better at that. But if we were going to square this guy here, if you needed to do that over here, remember that shortcut? I think I've mentioned it, but square this guy, square this guy. For the middle term, it's that times 2, so 8h. So there's that squared. So we're going to put that in. 4 minus 3 times 16 plus 8h plus h squared plus 44 all over h. And you guys can continue and probably do that as faster than me. Clean this up a little bit. Okay, so what can we've got a negative 48 and 48, is that going away? Okay, so we have negative 24h minus 3h squared over h. And what are we going to need to do? Because we're trying to take the limit as h goes to 0. So what do we need to do on top? Factor out the h. So that's h times negative 24 minus 3h over h. Bam, bam. And so the limit as h approaches 0 of that thing is what? Negative 24. So there's your slope. Remember that this is m that we just found. Once you have the slope, you use that point slope formula to write the equation of the line. What was the point we were given? 4, negative 44. So we're going to write the equation of that line. So our point, 4, negative 44, m is negative 24. So y plus 44 equals negative 24 times x minus 4. And then you just got to clean it up. I keep running out of room. Okay, so really not anything different than what we were doing before. We're going to just keep practicing that. You're going to get your algebra skills really, really good. So I'm going to let you work on the next one. I'm going to put it up here. You're going to work on it, and then I'll put the work up. Okay? So here is this one. Let me make it a little bigger. And it's asking you to do a little bit something different at the end. Find an equation for the tangent to the curve at the given point. Then sketch the curve and the tangent together. So once you get the equation of your tangent, you want to put this in your y1 and in y2 you'll put your tangent that you find, and you're trying to match one of these pictures. So the first thing you do is try to find the equation of the tangent. Okay? Okay. So our point was 1, 2. So it's y minus 2 equals 1 times x minus 1. Y equals x plus 1. Now you got to put that in the calculator. So in your y2, did you do that part? Okay, so in your calculator, you're going to go to y1 and you're going to put 2 square roots of x. And in y2, you're going to put x plus 1. And this looks like a standard window, although it's starting at the origin. So if you want to have that exact window, your x min would be 0 and your y min would be 0. And then you could get this. But you've got to pick which one of those pictures matches the best. What do you think? What? B? Is anybody, they look a lot alike. They look very much alike. That's what I'm trying to see. The slope of that line, I think it's this one. But if you do x plus 1, you start at 1. Well, they all start at 1, and then you've got to go up 1, up 1, up 1, up 1. But this one, I mean, it starts out with that same slope. But look at yours. Look at your, here's one thing you can tell. If you were trying to tell, if you said, what's the value of that line when x equals 9? It should be at 10. This one is not at 10. Of course, this one isn't either. It should be 10. Can anybody do that? Second calc value and put x as 9 on that straight line? You might have to turn the other one off. Do what? Did you get it? Okay. Did that show you that that was it? The differences are very subtle on this picture. But you noticed right away that it was this point right here. And one way to check that is to look at this guy in the calculator and do second calc value and say, what's my value when x is 9? Oh, it should be 10. This one is not going to be 10. This one's not going to be 10. So, I mean, you could find out what it is and then match the graph. Does that make sense? So look at that. Okay. All right. Okay. Same idea with this one. And this one is y equals 2x cubed. So you're going to be cubing some stuff. So your algebra skills get practice again. And you're doing 2 plus h. That's what you're plugging in. Okay? So I'm going to let you go ahead and do that. And you're going to do the same thing. You're going to end up graphing the curve and the tangent. Confusing. Okay, so let me just recap that. The big part was getting this cubic part right, which I didn't get right the first time. So plugging all that back in, I think I've made all the corrections. And we get down, your slope is 24, and you use your point slope formula. and you get y equals 24x minus 32. Okay. This one is kind of tough, and you will have to watch me carefully because I might have made a mistake on this one too. Let's look at this one. 7x over x minus 3 at 6, 14. Okay? In this one, and what I sometimes do is try to look at what the computer, what MathLab is going to give you if you ask for help. And they did this one a little differently. They did not use the f of x value here of 14. They used this as f of x, which y is f of x. I'm not sure. I tried to follow their pattern. I did follow their pattern because that's what you would see if you ask for help. So let's kind of go through this and see. It's the same idea. We did 7. We're not using the x or the y value. We're just using x and x plus h. You know, we're using the equations. We're not using this point per se. So I've got 7 times x plus h over x plus h minus 3. What did I do there? I just substituted x plus h everywhere there was an x. And I subtracted f of x. This is f of x. This is your original. It's kind of what we did when we did the difference quotient originally, way back in college algebra. All over h. Okay, does that in itself make sense that this is a little bit different approach? I'm going to get the same thing at the end. I think you probably could. I think it might be. I think it might be. But let's kind of go through this and see. Now the big deal here is what? We got to combine these fractions. What do we have to do? Common denominator. Okay, this looks a little ugly. Okay, here's the common denominator. And if you look at the step right above it, here's your, what did I just multiplied 7 times the x plus h and got 7x plus 7h times this denominator minus 7x times this denominator. That's what happens when you're combining these big ugly fractions. So I've got all of that on the top, and on the bottom I've got these two denominators multiplied together. That's the common denominator. And then it's all over h. So does that part, is everybody with me on that part? It was like I just combined these two, gave them this common denominator. Everybody okay? Then I started cleaning it up. And so you can see here, that's multiplying. This is where you need to see if I did it right. See if I multiplied correctly here and subtracted everything correctly. So check that out. If you're doing it, make sure that you kind of get what I've got. Make sure I didn't miss something or multiply wrong. I think that part's right. I think those are right on top. Anybody check me on that? Here or here? Here? Okay. You're lost going from here to here? Okay. So think about this, Dinah, in like if it was 1/3 minus 2/7. If that's what that was, that simple, would you know what to do with it? What would you agree that 3 times 7 is the common denominator? Right? And then 3 into this stuff, then you multiplied that up there and you got 1 times 7 minus 7 into that is 3, and you've got 3 times 2. That's exactly what we did down here. These two multiplied together. This is like your 3 and 7. They're multiplied together here. This one goes into this many times, x minus 3. So I multiplied it times this part. And then the same thing over here. It's just got a lot more stuff going on, but it's that same process. Does that make it a little better? Jeff, better? Which, no, that's a good question, but which, like, are you talking up there? Where did this come from? Is that what your question was, maybe?
It's on this right here, you do 7 times, 7x times x, 7x times h, and I'm multiplying both.
7x times x, which gave me this. X times 7h, which gave me that. And then minus 3 times both of them. Question, Jimmy?
Should you put another set of parentheses around on the top right section of that, where the 7x times 3 it's x plus h minus 3, it's going to, it looks like you're only multiplying the x plus x times 7x. That's right.
Right here.
Right. It looks like you're not multiplying the 7x times x.
So you want, because this was originally that, something like that. I actually need another one, don't I? Like there? Is that right?
Right.
Okay. Does that make you feel better? Okay. Is that cleared up for you? Thank you for bringing that up. We have to keep me honest and keep you clear. Okay? If you're a programmer, parentheses get really important. You got to open and you got to close. I do know that, but I missed that one. Okay. So I think here I've gotten this number right. Here's my denominator. All this stuff cancels out except the negative 21h. And since I've got this over h, what can happen? It's like this is this, and then when you flip this and multiply it, this h is on the bottom. They're going to cancel out. And so you've got negative 21 over this business. And as h goes to 0, h is gone. I've got x minus 3 times x minus 3. I end up with this. I can write it as x minus 3 squared. This is my slope, my general slope. I don't get a number. That's my slope. And what we're working towards is that's what we're going to do when we get a derivative. We're going to get a slope generally. And then we could say, what's the derivative at x equals 3? What's the derivative at x equals 9? So we're getting a general formula for the slope. And then if you want to take the slope of the curve at x equals 6, you plug in 6 here, 21 over blah, blah, blah. And so this is the slope at x equals 6. On curves, the slope is different at every x point that you have. So you don't have just the slope is 5. It's 5 at this x point, but it might be 3 over here. So at 6, that's the slope. Does that make sense? Sort of. And then we go ahead and write the equation of the line, which has fractions and everything in it. And when you get ready to do that on MathLab, it's going to want fractions, not decimals. So be sure that you can do that. Yep. How far? There? Okay. Yes. I think so. Hope so. Yeah. It's good that these aren't, film quality. Okay. Jeremy, let me know when you're good. Okay. All right. So let's go back and look at, what are we on? Number 5?
So you divide 252 by 9 and you come back to
here?
Yeah.
You could. If it did. I just didn't do it because I was working in the fractions, but yeah. Yeah, 28. It's asking for the slope of the tangent line at x equals 6 and then it asks for the thing. Did we have to match the line? Yeah, we did, didn't we? No, we didn't have a picture on this one. It just wanted the slope at that point and then the equation of the line, tangent line at that point. So we found both those things. Okay. All right. Let's do number 5. Slope of the following curve at x equals 6. 1 over x minus 2. 1 over x minus 2. This one should not be as bad. I'm going to put us on pause and let you work that. Okay, so this is the work, but let's kind of look at it. One of the things that you'll find in questions like this is sometimes they just say the slope of the given curve at x equals 6. Well, sometimes you need to know what the y value is at 6. In this case, maybe we do. If we're going to use 6 in our formula and not use x plus h, we did. So when x is 6, you plug in 6 and you get that this is 1/4. Okay? Then we're going to plug in 6 plus h for x. So we've got 1 over 6 plus h minus 2 minus our f of x value, which is 1/4 over h. So clean that up, and you've got h plus 4, and you've got 1/4. And then we do that common denominator thing again. If you multiply 4 times h plus 4, that's the common denominator. And what happened here? H plus 4 into this thing is just 4. Multiply it by 1, you get 4. Minus 4 into this thing is h plus 4. Multiply it by 1, you get this. Okay? And so what happens? I've got 4 minus h minus 4. The 4's are gone. I've got negative h over this stuff. And I went ahead and wrote it as times 1 over h. That's this thing here. Okay? Those are going to cancel out, and what's left? Negative 1. Don't forget that. Over this. Then as h goes to 0, you get negative 1 over 16. Did we get that? Somebody get that? Okay. Good, good. Jeremy? No? Yes? Question? It'll come back. I promise. Okay. All right. Same idea on this one. I'd like you to look at this. We can do this together, but I can't make that bigger right now. All right. An object is dropped from the top of a cliff 640 meters high. Its height above the ground t seconds after it's dropped is. So here's the function. 640 minus 4.9 t squared. So that's the height, and t is time. Determine its speed 3 seconds after it's dropped. Okay, we're talking about speed. What is speed? Anybody? Physics? Is that a derivative? Well, acceleration, velocity is the first derivative. Acceleration is the second derivative. But speed is it the absolute value? Okay. But in any case, we got to find a derivative. We got to find the slope of this thing. So we're given an x value, t equals 3. We need to know what s of 3 is. So that means plug 3 into this thing here. You get 640 minus 4.9 times 3 squared. If you do that on the calculator, you're going to get 595.9. So now I have a t value and I have an s of t value. That'd be like your point that you're used to seeing. Okay? So the limit as h approaches 0 of, here is this with 3 plus h put in for t, minus the y value. Yes? No? Keep going. All over h. So this is f of 3 plus h minus f of x or f of t, whatever, s of t, whatever the y value is of that point. That's what we've been doing each time. Okay? You didn't get that point? Did anybody else get that point? Anybody check that math for me? You're talking about you didn't get this 595? Where? Here? How did we do that? Okay, here's the original function. And so instead of t, I put 3 plus h because 3 is the x value. And so then you're going to square this. And then it's subtracting the original y value. S cubed? Well, S cubed, what, I mean, that's not S cubed, it's the night for mistakes. Thank you. Yeah. Does that make sense? Because here I wrote it right. Here, S of 3 equals this, and you were trying to figure out where S cubed comes from. No, no. No, no. Okay, it's Monday, Tuesday, Wednesday, Thursday. Okay, right. See, I don't even know what day it is. Yeah, just off. I know. So, well, let me, okay. Okay, all right, never mind. That was bad. All right, so when you square this, we've got this here. And where did this go? Where'd this go? Away. 640 minus that is this. Okay, so I just got rid of him there. And I've got minus 4.9 times this. Then I did that multiplying. Please check my math. Because these guys canceled out and I had where did I? No, I didn't. I didn't. I didn't. I'm going to turn this off. Should we just go home? It's awesome. Okay. Do what? Oh, I'm sure. Yeah, it sounds good, doesn't it? Okay. So when you distribute correctly, you get this, and then these cancel out. Factor out h, you got negative 29.4 minus 4.9h. When h goes to 0, you are left with negative 29.4. The negative indicates that it's falling down. Okay? All right. Now, last, I think this is the last one. 7, maybe? Oh, almost. A few more. Okay, try this one. It's the same idea. We've kind of got a word problem. What's the rate of change, is that slope, of the area of a circle with respect to the radius when the radius is 3? So it's saying, how's the area changing when the radius is exactly at 3? Same idea though. Here is your main formula. You've got an x part of your point, that's 3. When r is 3, what is the area? 9 pi. So you've got 3, 9 pi. That's your point that we've been using with an x value and a y value. Working? Do what? Yeah, it's the a value. Because a is like a y and r is like a x. So your original function is here, and you're going to substitute in 3 plus h for r. That's like your basic formula. Like as if that were 3x squared, you'd substitute in 3 plus, okay. Got it. Just waiting to see what mistake I made on this one. If I gave you a circle and I said the radius is 3, what's the area? It's pi times r squared, so it'd be 9 pi. If you didn't get it. That's exact. And you use 3.14 to get a pi. Yeah. Yeah. Did we find any mistakes? Not on that one. I love that. Not on that one. You're okay. All right. So did we got 6 pi? Good, good, good. Okay, so are we remembering that whole process where you have an x value, you're going to use that f of x plus h minus f of x over h, the limit as h goes to 0 to get your slope. Your slope of the tangent line is the derivative. And soon, very soon, you won't be doing this. You will just know how to do the derivative, and it'll be a rule, and you'll just say, why did I ever do this? How many of you guys have done that before? Yeah, yeah. So you're just really aggravated with doing that, I'm sure. I remember being aggravated myself. Okay, let's look at, oh, go back. Okay, is that enough? Okay. I think we have one more. Good. That's a good thing. Okay, let's do this one. Make it bigger. Okay, use technology, hopefully, to answer the following. Graph the curve. We've got 5 parentheses x minus 1 to the 2/5. So we're going to go in, and in y1, we're going to put that. I would put it in like that and see what kind of curve we get. You get something like that? Okay. When you do that, it says, where does it appear to have a vertical tangent? Like a vertical tangent would be something coming down in a vertical line that would be tangent to the curve. Where does it appear to have one? Right at x equals 1? Okay. So that's what you would put here. Just by observing, it would be at x equals 1. But then it says limit calculations show the vertical tangent exists or doesn't exist. So, but we gotta do that. It doesn't, and if you've had calculus, you know what is this called down here? Cusp. And we don't have, the limit doesn't exist there, the tangent doesn't. So the derivative doesn't exist there, but we got to show that. So how would we do that? How would we do that? At x equals 1. Okay? What is y when x is 1? 0? Okay, so y is 0. So we have a point, 1, 0. And we can do that with this thing. We have 5 times 1 plus h minus 1 to the 2/5 minus what? What's our y value? 0. Oh, yes. It's the y value. So when x is 1, well, it should be 0 if you look at the function. I'm not looking at the picture here. What happened to my thing here? Just doesn't show it. But if x is 1, you got 1 minus 1, you're at 0. So it's got to be 0. Even though it doesn't look like it. Did you get it? Yeah, and put in x equals 1. Okay. All right, so here we go. Limit as h approaches 0. What do we do here? What happens here? Do I have 5h to the 2/5 minus 0 over h? Can we do that? I can't do that. What are you going to get as you approach 0? Remember when did we have some limits that ended up at infinity? Mm-hmm. Would we get two different things if we come in at 0 from the left? And if you look at your picture, you're seeing that. Where's it going there? Is that going to negative infinity? And this one to positive infinity, which is happening. All that they're trying to get you to see is that it looks like it has a vertical tangent, but the derivative doesn't exist, the tangent doesn't exist, the slope doesn't work there because it's going to infinity. And so when you do this problem, and I do not know what happened here. It was showing, wasn't it? Let me go back over here. Okay. When you go here, it'll be does or does not, I think, as your choices, and it doesn't exist. So it appears to be at x equals 1, but by doing the calculation, you see that it's not. There isn't one. Yes, sir. Oh.
How does h drop down?
How does this do that? Okay, when you have h, okay, h to the 2/5 over h. What do we do when we have exponents? And this is like 5/5 because it's h to the first power. So that's h to the negative 3/5. Yes, and I didn't write that on the other one. But so you end up with 5 over h to the 3/5, which you're going to have 5 over 0. And that's why we're going to infinity. Remember when we were doing those limits as we went to, if you had 0 on the bottom, your answer was going to be infinity. In that last, we didn't have one on the test that looked like that, but we did get those. But that's what happened here, equals h to the negative 3/5, and so it goes to the bottom because it was negative. Thank you for pointing that out, Jack. Okay, any questions on that? Okay, so you know what you're expecting on that. All right. Okay.